Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about instantaneous rates of change.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals 2x squared minus 2, and we want to find the average rate of change over the interval from 1 to 3 halves. Now, we have our graph here. To show we see it's a parabola. Okay. Now I'm going to put the graph away for a moment, and we're going to try to do all the math there and then look at it again at the end. So what we have is we want to find first the average rate of change. So we're given the x values here. We need to find the corresponding y values. So let's go plug 1 in for x, and what do we get? We have 2 times a 1 squared minus 2. Then we want to simplify this. Well, 1 squared is 1, times 2 is 2, minus 2, and that's a 0. Great. Let's do the same thing with 3 halves. 2 times a 3 halves squared minus 2, and this just comes out to be a 5 halves. I won't bore you with that part. All right, so we have our corresponding y values with our x values. So let's go find our rate of change here. All right, that's our delta y over our delta x here. We take our y2, 5 halves, minus our y1, which is 0, over our x2, 3 halves, minus 1, or x1. Simplify that out. We have 5 halves over a 1 half. And that simplifies to be a positive 5. So our average, right here, the average rate of change is 5. But we also want to find the instantaneous rate of change right here, the instantaneous rate of change. Well, to do that, we have to use our definition of our limit here. So what we're going to do is take the limit, all right, as h approaches 0 of our, we're going to find f prime of x here. Let me shove that in. Okay, of our function. Now, our limit says we take our function to, we have an x, instead of an x, put an x plus h in, squared, minus 2, minus our 2x squared minus 2, like that, all over our h value. And now what we're going to do is we'll simplify what we can in the numerator. We have the limit as h approaches 0 of, this thing simplifies, we have a 2 times an x squared plus a 2xh plus an h squared, minus a 2 minus 2x squared, distributing this part out, plus a 2, all over h. Let's keep going. It's a lot of writing of limits here, but don't worry, eventually in calculus you won't have to write that out every time. You'll learn something new. Well, we have 2 times x squared, we distribute this out, so we have a 2x squared plus a 4xh plus a 2h squared minus a 2 minus a 2x squared plus a 2 all over h. All right, so now here I'm going to try to cancel out what I can. Well, I see there's a 2x squared and a 2x squared right there, negative 2 and a positive 2. And actually I can cancel out some of these h's. We have an h here, cancel out this h and this squared. So we're left now with the limit as h approaches 0 here of what's left over is just 4x plus a 2h. It's now at this point that we can take the limit by plugging 0 in for h, and we have 4x plus 2 times 0, which is just a 4x. And that's equal to our f prime of x. Now they tell us that I want to use the leftmost value of our given interval. So that's a 1. So to do that, we have f prime of 1 here, we're trying to use here, and that's 4 times 1, which is 4. And so our average is 5, our instantaneous rate, if I can spell, is 4. And again, our graph, I'll put it back up here, but there's our graph for our function, and at the interval from 1 to 3 over 2, the x values there, our average rate of change was 5, but right there at 1, the instantaneous rate of change is 4. We're given this problem right here, y equals a negative 1 over x minus 3, and we want to find the average rate of change over the interval from 0 to 1 half, and the instantaneous rate of change at 0. Well, our graph here, we can see what it looks like, but it's kind of tricky. We're using a small interval from 0 to 1/2 to find the average rate of change, and instantaneous right there at 0. Okay? Now I'll put the graph away for the moment right now, and so we have plenty of space to work. Let's go find the average rate of change first. Now, we have our x values here. We need to find the corresponding y values. So I'm going to plug 0 in for x. So we have a -1 over 0 minus 3. And what does that come out to be? Well, that comes out to be a simple, just positive 1/3. So 0 minus 3 is a -3. Negatives cancel. So do the same thing with the 1/2. We have a -1 over a 1/2, and for our x value, minus 3. And this comes out to be, I wrote it down here, a 2/5. Okay. So we have a 1/3 and 2/5. So let's go find the average rate of change here. So we use our formula, right? Our y2, so our delta y over our delta x, change in y over change of x, is equal to 2/5 minus a 1/3 over a 1/2 minus, make sure I did it in the right order, make sure I don't have the wrong problem there, yeah, minus 0. That comes out to be 2/5 minus 1/3 is a, well, let's do the whole thing. 2/5 minus 1/3 over 1/2 minus 0 comes out to be a 2/15. And so our average here, I wrote a delta, but average rate of change is just a 2/15. Now the hard part's the instantaneous rate of change, and that involves our definition of a derivative. So we're going to find the derivative here using the definition of a derivative here, and then we'll find the instantaneous rate of change at 0. So our f prime of x is equal to the limit as h approaches 0 of our function, a -1 over a x plus h in for x minus 3, minus our f of x, a double negative, be careful there, over an x minus 3 over h. Okay. So what we can do as part of our process was, see that right here, plus a positive, make that fix. We have the limit as h approaches 0. And again, I'm going to basically combine these two fractions by having the common denominator. I'm going to put the x minus 3 in this numerator, and let's distribute that minus sign while we're at it. Minus x plus 3 is up there. And then we're adding here this denominator, which is an x plus h minus 3. All of that's going to be over these two denominators being multiplied, x plus h minus 3 times an x minus 3, and all of that is over h. Okay. Well, luckily our numerator here, we can see some things cancels. The negative x, positive x, 3, and negative 3. So if we rewrite this as the limit as h approaches 0, we have just an h up top, and the denominator was that x plus h minus 3 and an x minus 3 here. And if we divide by that h, is the same thing as tossing the h right there, which is great because these h's cancel. So again, taking that limit with all the space we have here, the limit as h approaches 0, we have a 1 over an x plus h minus 3 and an x minus 3 here. We now can take the limit as h approaches 0 because we can directly substitute it in, and we just have, well, that's just plus a 0, doesn't do anything. So we have a 1 over an x minus 3 times an x minus 3. If we want to simplify that out here, we have a 1 over a, what is that, a, multiply that out, that's x squared minus a 6x plus a 9, and that's equal to f prime of x. Now they want us to find it right there at x equals 0, right, the instantaneous rate of change. So we want to find what f prime of 0 is, so we plug 0 in for x. 0 squared minus 6 times 0 plus 9. Well, it's easy when it's zeros. They cancel, we have 1 over 9. And so our instant rate of change here is a 1/9. And again, you can see the graph here. Our average rate of change over our interval from 0 to 1/2 is 2/15, while the instant rate of change right there at x equals 0 is 1/9. we're given this function right here, y equals x squared plus x plus 2. And we want to find the equation of the secant line that intersects our given points, -1, 2, and -1/2, 7/4, as well as the tangent line that goes to the leftmost point, which is -1, 2. We got to sketch both of these lines. Now, we can see our graph for our equation right here. Okay, just briefly, I'll put it away in a second. And we want to go first let's go with the secant line first. So let's do the secant first. Equation of the secant line. Well, we want to find our slope using our slope formula. Pretty easy. We're given the 2 points right here. 7/4, this is just algebra, guys. -2 over a -1/2 minus a -1. y2 minus y1 over x2 minus x1. This comes out to be a -1/4 over a 1/2, which is a -1/2. All right, we got our slope here. Our formula for y equals mx plus b, so we have y equals a -1/2 x plus b. And let's go find, well, the equation of the line. We can use the first point here, -1, 2. I think it's the easiest. And this, again, is just algebra. You should know that. -1 over 2 equals -1/2 times our x value, -1, plus b. And this comes out to be a b value of 3/2. I won't bore you with that part. So our b value is 3/2. So our equation of the secant line just comes out to be a y equals our slope, -1/2 x plus a 3/2, which is our b value. So that's the equation of the secant line. Now we want to find the equation of the tangent line, and we're going to use our definition of the derivative to help us out there. So it's going to take some work here. So right here, let's go with the tangent line. Right here. And our first step, let me kind of mark that off. First step, we want to find, well, the derivative of our function. So our definition tells us that f prime of x is equal to the limit as h approaches 0 of our function. Right here, we're going to put an x plus h in for x. So we have an x plus h squared plus an x plus h, I'm running out of room here, plus 2, minus, I'll shove it down here a little bit, we have the x squared plus x plus 2. All of that is over our h value. Okay, so I'm going to actually, let's do this so I have a little more room here. Let's go simplify that. The limit as h approaches 0 here, okay, what we're going to do is really, I'm going to multiply a whole bunch of stuff out in that numerator. Okay, so that x plus h all squared comes out to be an x squared plus a 2xh plus an h squared. Then we have a plus x plus an h plus a 2 minus an x squared minus an x minus a 2. Notice we have to distribute here all those parts. All of that is over h. Okay, so it's at this point I try to see if there's things that I can cancel. X squared here cancels with this negative x squared. X and a negative x, and 2 and a negative 2. So let's get a better picture here. We have the limit as h approaches 0 of a 2xh plus an h squared, right there, plus just that h. And all of that is over this h. Now, if you need help seeing this, but I'll take the time. This one's a little tricky, actually. Usually you can cancel all these out, which you can. Just be careful, that's going to be a 1. We're going to just pull out the, well, h's here. Right, you'll see that here. And pull out h in the numerator. So we have an h out, we have a 2x plus a 1h plus a 1 over the h. And this is where you can see the h's cancel pretty easily. So if you can do it within it, great. If you need that step, fantastic. It's all good. Keep on going here. We have the limit as h approaches 0. And we just have a 2x plus h plus 1. And it's at this point that we can take the limit directly. Taking the limit directly, we plug 0 in for h. We just get a 2x plus 1. And again, that's equal to our f prime of x. Now they tell us we want to find the equation line at the leftmost point. So that's at -1, 2. And we want to find the slope there at, well, the x value, -1. So that's all we care about. We take our f prime of -1, and put that up here, f prime of -1, and that's going to be a 2 times a -1 plus 1. Well, that comes out to be -2 times a -1 is a -2 plus 1, and we have a negative, well, 1 here. So our slope value here, our m, is negative 1. So now it's the same process as before. We have y equals our slope negative 1, slope times our x value plus b. Now, here's a tricky point. We have to use our point to find our b value, and we have to use this coordinate point there. Okay, the first one. We don't have the option of using both here. So 2n for y equals a negative, 1 is a negative, times x value negative 1 plus b. And that comes out to be here a b value of a positive 1. And so our tangent line, I'll put that over here, our tangent line, combining it all together, is a y equals a negative x, the m value, plus 1. Okay? Now, when we bring the graph back up, we might cover some of the stuff here. With the graph back up here, and what can we see? Well, we can see our equation of our line, x squared plus x plus 2, and what we have is the tangent line, the secant line between the intervals negative 1, comma 2, and negative 1/2, comma 7/4, as well as the instantaneous rate of change happening at the tangent line at negative 1, comma 2 with our second equation here. And so our two equations, to sum it up here for the secant line, our secant line is y equals negative 1/2 x plus 3/2, and our tangent line is equal to y equals negative x plus 1. We're given this problem right here, y equals 1 over x plus 2, and we want to find the equation of the secant line between the 2 points, negative 1, comma 1, and negative 1/2, comma 2/3, as well as the tangent line at our leftmost point, negative 1, comma 1. We're going to sketch both of these graphs. Well, first let's go find the secant line. Now the secant line involves, well, we already have the point, so we got to find the slope, right? So let's go secant here. And basically it's just the equation between these 2 points. Excuse me, because they were given to us. So our slope is equal to our y2, 2/3 minus our y1, which is 1 over a negative 1/2, x2 minus x1, a negative 1. This comes out to be a negative 1/3 over a 1/2, which hopefully you're pretty good at doing, as a negative 2/3. And again, that's our slope value. Well, to find the equation of line, it's y equals mx plus b. So we have y equals a negative 2/3, our slope, x plus b. And we can pick any point here to find the b value. I think the first point's easier. 1n for y equals a negative 2/3, and x is a negative 1 plus a b. Solving for that, simplify this, and b comes out to be a 1/3. So our equation of the secant line combining the two is a y equals a negative 2/3 x plus a 1/3. And there's our secant line. Now let's go find the tangent line. This one's more difficult. Okay? Because we're going to use our definition of a derivative here for that. And the first thing I want to do is I want to find the definition, or find the derivative of our function using the definition of the derivative. Now, I flipped over here. Okay. So, with that being said, I'm going to say we want to find f prime of x here is equal to the limit as h approaches 0, okay, of our function right here. Now, oh wait, no, I'm good. Make sure I have it written right here. All right, of our function, just keep my notes there. 1 over, instead of an x, I have an x plus h plus 2. Subtracted by our f of x, which is 1 over an x plus 2, all over our h value. Okay. Now with that, I'll rewrite it over here so it's a little easier. One of the common techniques here with this is we want to find a common denominator, so we're going to multiply these two together and then bring this numerator up here and this one up there. So we have an x plus 2 up here. We're going to be subtracting that by this denominator, which is an x plus h plus 2, all over multiplying these two together. We have an x plus h plus 2 times an x plus 2, and all of that is over h. Now, let's go distribute this minus sign up here, and things are going to cancel. We have the limit as h approaches 0. We have an x plus 2, distribute that over. We have minus x minus h minus 2. All over this big old denominator. Now watch this, actually. The whole denominator right here we have the x plus h plus 2 and x plus 2 here. And we're dividing by that h, by everything. We actually can just toss it here. They're the same thing. Now let's look what cancels. The numerator here, x cancels, and this x cancels, or negative x, and 2 and negative 2. We can keep this gravy train going. This h here and this h cancels, leaving us with a negative 1. That's right there. So this limit here, as h approaches 0, is equal to a negative 1 over this whole denominator. X plus h plus 2 and x plus 2 here. At this point, we can take the limit. Taking the limit here, we can plug h, or 0 in for h, and we have a negative 1 over, well, can't really add a 0, so we have an x plus 2 and an x plus 2. And this simplifies to be a negative 1 over, multiplying that out, x squared plus a 4x plus a 4. And again, that's our f prime of x. So making sure my notes are all good now. I have the right value here, x prime of x, which I do. We're on the right track. So with that, we have our f prime of x. We need to find it at our leftmost value. So we only care about this x value here of the first point, negative 1. So let's go find what f prime of negative 1 is. Well, using our equation here, negative 1 over negative 1 squared plus 4 times a negative 1 plus a 4. Simplify that out. We have a negative 1 over, well, negative 1 squared is a 1, and then we have, well, minus 4 plus 4. The 4's cancel here, and we're left with just, well, a negative 1 when it's all said and done. And so our slope value right here for our equation line is just a negative 1, right? That's the instantaneous rate of change for the tangent line at our negative 1, comma 1. Well, we have to find the b value just like we did before. So we have y equals our negative 1, our m value times x plus b. There we go. Well, our y value has to be from the first point, which is a positive 1, equals a negative 1, right, it's a negative. Our x value here at the first point is a negative 1 plus b. The negative times the negative is a positive, so we have 1 equals 1 plus b, and b equals, well, 0. So our b value is 0, m value is 1, our negative 1, so we can write the equation of the tangent line as y equals just a negative x there, don't have the plus b. And so we have our secant line, which is y equals negative 2/3 x plus 1/3, and our tangent line is y equals negative x. Now we can sketch that or see that here on our graph. Notice that the first equation, the secant line, is through the interval of negative 1, 1, and negative 1/2 and 2/3. While the second line, the tangent line, is only there at our negative 1, comma 1 value, and it's a tangent line at that point. So again, our final answer, the secant line is y equals negative 2/3 x plus 1/3, and our tangent line is equal to y equals a negative x. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.